Our next task in the process is to select the technology stack of the services. Now, in monolith apps, this task has a lot of weight. It sets the technology stack of the whole application, and once set, it's quite difficult, even impossible, to reverse. But in microservices, the situation is different. The decentralized governance attribute of microservices allows selecting different technology stacks for each service. This gives the team a lot of independence in selecting the stack and allows them to pick the most efficient and suitable platform for their specific task. In this lecture, we will focus on backend development platform and storage platforms, since these are the most critical ones for microservices. We are going to lay out the various alternatives for backend and storage and explain the pros and cons of each one of them. Now, it's important to note that rarely there is an objective right or wrong when discussing technology stack. Basically, you can get the job done no matter platform you will use. However, there are some considerations you should take into account when making that decision, and I want to make sure you're aware of them. Another thing to note about this topic is that it's extremely important to make this decision based on hard evidence. Technology stack discussions tend to become quite emotional for no apparent reason, and you want to stay away from these discussions. Make your decision or recommendation based on facts and figures, and beware of falling in love with one platform or another. Okay, so let's begin. First, we are going to talk about the backend development platform. Now, I've decided to make your life easier, and instead of going through each and every platform and explain the pros and cons, I've made you a great summary you can use when deciding on the development platform. And here it is. So what you see here is a table comparing the currently leading 6 platforms with various factors you can compare. The platforms described in this table are .NET, .NET Core, Java, Node.js, PHP, and Python. So let's go quickly throughout this table. The first column is app types, which means what kind of applications can we use this platform for. Now, when talking about microservices, the application type we will use is usually Web API, because this is what typical microservices expose. So we first have to make sure Web API is supported by the platform, and it looks like all of them support this, so we're good. Next is the type system. There is an important distinction between static typed languages and dynamically typed languages. With static types, the developer sets hard-coded types for the variables, objects, method, etc. And if a mismatch is found, such as putting a string value in a numeric variable, a compiler error will be thrown. With dynamic languages, on the other hand, no such limitations exist, and basically you can put whatever type of value wherever you would like. The advantage of static languages is that errors are found in the development phase by the compiler, and so the system is more reliable once in production. The advantage of dynamic languages, on the other hand, is faster development. The developers don't have to think about types and can be more flexible in their assignments. Now, which one to choose is more of a personal taste, and there are pros and cons for both, but you do need to be aware of this difference between the platforms. One important thing to note is about Node.js. Node.js is based on JavaScript, which is basically a dynamically typed language, but one of the interesting trends that developed in recent years is to use TypeScript, a statically typed language based on JavaScript developed by Microsoft and quickly became one of the most popular languages as the language for Node.js. So this basically means that services developed with Node.js can be either static or dynamic, depends on the exact JavaScript flavor you will use. Next is the cross-platform factor, which is very important. Nowadays, we came to expect our development platform will be cross-platform and will run on all major operating systems, from Windows to Linux via OS X. As you can see in the list, there is one platform that is not cross-platform, and that is .NET. This means you should consider it only if you are sure the application will run only on Windows. Otherwise, don't even think about it. The next thing you should look at is the size of the developers community around the platform. The developers will use this community a lot during development, and it's better to have a large, vibrant community that can actually provide help. The next factor is performance. It's quite clear what this means, and you should always strive to use the platform that provides the best performance possible, unless the system you are working on does not need high performance, which might be the case with desktop apps. But with microservices, performance is always an issue, and you have to make sure the platform will help you with that. The last factor is the learning curve. If the developers do not have prior experience with the development platform, it's important to make sure bringing them on board will not take too long. So this is another factor you need to consider. Now, my personal favorites in this list are .NET Core and Node.js, and this is what I usually recommend to my clients, but your mileage might vary. Great, so this is the development platform, and now let's move on to the next technology stack we need to decide on, the data store. So when talking about the data store, we actually talk about 4 types of storage: relational database, NoSQL database, cache, and object store. So let's explain each one of these types. So first, relational database. This type of database is the traditional database. It stores data in tables, which have concrete set of columns. For example, here is a typical table that can be found in a relational database. In addition, relational databases have the concept of relationships. So, for example, if we have this table storing orders details, and we need also a table to hold the items of each order, then we can define such table and connect the tables through a relationship column, in this case, order ID. The order ID column in the items table points to the order in the orders table to which these items are belong. So this is a relationship in a relational database. There are quite a few relational databases, for example, SQL Server, MySQL, and PostgreSQL. You should use relational database when the data is fully structured and you will need complex queries, where relational databases traditionally excel. The next type of data store is NoSQL databases. This type of database put emphasis on scale and performance and less on data complexity or advanced queries. These databases are usually schemaless, meaning as opposed to tables, in relational databases there is no well-defined structure to the data records, and each record can have its own fields and types. With NoSQL databases, data is usually stored in JSON format, which allows nesting and some level of querying. Similar to relational databases, there are also quite a few NoSQL databases, among them MongoDB, which is the most popular of them by far, Amazon DynamoDB, Couchbase, and Azure Cosmos DB. You should use this type of database especially when your data is semi-structured. You don't need advanced querying capabilities, and you do need scale and performance. These databases are usually used for storing logs and telemetry data. The next one is cache. Cache stores in-memory data for fast access. It is used in conjunction with a database, and its goal is to bring the data closer to the application and store it in a fast access medium, such as in-memory, to accelerate retrieval time. It is used mainly to store data that is accessed frequently and rarely changed, such as zip codes or list of countries. Modern, sophisticated cache engines distribute data across nodes and thus can achieve large scale and redundancy. This type of cache is called distributed cache. Distributed cache uses a proprietary protocol to communicate with the nodes, a protocol that is extremely fast and with minimal overhead, and this is one of the ways they can achieve such great performance. Distributed cache, as opposed to regular standalone in-memory cache, stores only serializable data. It cannot store complex binary objects, and to be frank, it also shouldn't. It's almost never a good idea to do that. So, which cache engine should you go for? Well, actually, today there is one cache engine which became the most popular one and the de facto standard in the industry, and this is Redis. Redis is an extremely simple cache, provides great performance and storage capabilities, and is flexible enough to allow some sort of querying on the data. So that would definitely be the recommended cache to use. The last storage type is object store. Object store is used to store unstructured large data, such as documents, photos, files, and more. Now, true, you can use the file system to do that, but the file system has its own problem. Files can get locked, the authorization mechanism is complex, and they are usually managed by the sysadmin of the organization, which not always knows what file shares are needed and why, and accidental deletes can and will happen. So it's always a good idea to use a specialized engine for that. Which tools should you use for this? Well, the list here is quite short. We have the cloud storage engines such as Azure Blob Storage and Amazon S3, and we have also tools such as Minio that simulate the S3 API to provide object store on premises, but that's about it. My strong recommendation is this: whenever possible, use one of the cloud storage engines. When not, use tools such as Minio to simulate object store as plan B. So that was our overview of the object storage options and of the technology stack in a whole. I hope you are now well equipped to select the right technology stack for the microservices you are working on, and that you know what to look for in this process. As usual, if you have any question regarding the materials we talked about, please do not hesitate to contact me, and I promise to help you as much as I can. And now let's move on to the next lecture.